got you backed out here where you can see my setup, and what I need to do now is we're going to start working on cutting that angle on this flange here, and it's a 20-degree angle. I measured it over on the original one, and what I've done is I have rotated my compound to 20 degrees, and we'll be using this to come in there and just manually cut out that taper there. And what I want to do is I basically just want to get it where the taper starts right there in that bottom and comes out up here at the top, wherever it comes out. I should have plenty of extra material on the other side, so that's kind of where we're at. Let's start cutting. So we'll just come in here and start. I'm going to probably cut from both directions. It'll probably cut a little bit better coming towards me, but for roughing, it won't really matter. This 4140 can be very stringy stuff. Getting out here kind of close to the end. I'm kind of pulsing my cutter so that I break those chips up. They don't get quite as long and stringy. At least for these roughing passes, seems to be helping. And of course, as soon as I say that, I get a bird's nest. And that's got our angle on our flange cut. I will just comment here, you look at the flange that he sent me, and you know, it starts at a much larger diameter before it goes into the taper. He purposely wanted me to do it this way because of the way the table saw is. This flange comes up and just barely clears the edge of the cutout where this comes through. So it really needs to be that angle all the way on out. We're gonna have to it'll shift the edge of the saw blade over a little bit on his saw, but he can deal with that a lot easier than he can. He can't deal with making the slot that it comes up through in the saw itself different. So that's the reason we're doing it this way. Next step here is I need to go ahead and get this shaft down to its final dimension, which is 17 millimeters. And like I mentioned before, I don't really work in millimeters. My lathe is not set up to work in millimeters. It's made to read in thousandths, so I'm going to work in thousandths here. So we're at basically 750 thou right now. I converted 17 millimeters. That comes out to 0.6692. I also checked the original shaft over there, and it measures exactly 0.6692. So we're going to be going real close tolerances on this. We're going to try to hit that down to the 10,000th of an inch, and that should get us right on that 17 millimeter number. So let's go ahead and start whittling this thing away. Come in here and touch off again. And I'm just going to do about a 50 thousandths cut here. I'm going to take another 10, 20, I'll just do 30 thou right now. We're going to sneak up on this final number, so 10, 20, 30. Yeah, I lost some footage there. I'm not sure exactly where the camera shut off, but kind of catching you up here. I've been slowly turning this down, getting down to that final dimension. We're shooting point for 0.6692, which equals 17 millimeters. That is exactly 17 millimeters according to the conversion, and that is also exactly what the other shaft on the original Arbor measured. And I am down to within about 2 thou of my final measurement. I'm using my micrometer here because I want to get a real accurate measurement, and we're a little over 2 thou from where we need to be. So I'm to the point where this shaft has got a little bit of heat in it, and I think what I'm going to do is let this cool down before I go any further. When you're trying to hit a measurement to a 10,000th of an inch, just a little bit of warmth in there can cause that metal to swell up, and it can make a little bit of a difference in the final measurement. So we want to take our time here, make sure we hit that number right on, because we can't really put metal back on there. Guys, I got down to within a couple of tenths of where I needed to be, and I've just been kind of coming in here with some emery cloth, and I've been coming in here with some emery cloth and just kind of polishing this. There's a little bit high areas, and should be right there where I need to be. Let's come in here and measure. I know you guys probably can't see the micrometer. We're at 19. We're right at 2, just a shade under 2/10 there. 19, we're right on 2 there. 19, yeah. So we're measuring good across here. I think we're fine. We're within a 10,000th of an inch of what I'm shooting for all up and down this. So all they've got to do is just have some bearings slide over that. So I think we're going to be fine. And the final thing to do on this side, I need to turn this down to 5/8 inch on the bottom and thread that. So let me get some measurements and we'll do that final little step there. I'm here to touch off. We got about roughly 50 thousandths to take off of this, not quite 50 thou. 10, 20, 30. I got a mark on there, it's a 1/2 inch in. And like we got about 12 thou to come off. Right on the money. The original has a pretty heavy chamfer there on the end, so I'm going to do the same thing here. Just come in here with this little chamfering tool. That looks pretty good. And let me get it set up for threading. I need to double check this thread pitch real quick. My thread pitch is 5/8, 18. So I've got my lathe set to 18 threads per inch. I'm gonna come in here, we'll touch off there. Let's make a scratch pass here and we'll check our thread pitch. Yep, we're on 18. Let's cut these threads. Getting close. I think I'll do a scratch pass across that. We'll do a test fit here. All right, we're coming in here with our nut to just do a test fit, and it's screwing up on there just fine. So I think we're going to call that good. I'm going to put my part back in here. That's another nice thing about turning between centers, is even though I took that part out, as long as I get my dog back over here on the same jaw that I was on and I marked it, if I needed to come back in here, it would have been timed just right, and I would have been fine to finish threading that, which is a little bit counterintuitive if you're used to doing it in a jaw or jaw chuck. All right, I think that we have this side pretty well done. I'm gonna come in here and take one more set of measurements on everything. If needed, I'll get some emery cloth in there and polish a few points. I'm gonna take real good time and just hit every little spot and make sure we got it. But I think that we got from this end of the shaft done. I've turned my part around now, and I've got a drive dog here on the back side, and notice I took some brass shim stock and put in there to protect that shaft. I didn't want to be clamping down directly on there, but that should help protect that right out. Back on this side, we've got to turn this arbor down to 5/8. That's going to be threaded with the left-hand Acme thread. Also need to work on this face here. Let me get the original part and kind of show you what we got. So you can see the original back here, and you know, our flange is forward a good bit farther than what it used to be. And what I want to do is I want to take this part down and thin it down. I'm going to leave this out here on the outer edge, not very much thickness at all. I want to get it as thin as I can with still leaving some rigidity out there, and because that is moving the saw blade over in his saw. So anyway, let's get in here and start whittling away at this thing. All right, guys, change in plans here. I was having some trouble with that dog on the end. It was slipping on me, and out here on this flange, I broke one insert. I changed out the insert. I tightened it up. I went back to it again, and it gave me another trouble. So I said, to heck with it. I'm just going to put it in the 4-jaw chuck. So I got a 4-jaw chuck here. I got some brass liners in there to protect that shaft back there. And I went ahead, I did this off camera, but we just got it indicated in. Fortunately, I'd already turned these surfaces, so I was able to indicate off of those. I got it running well within less than 1/1000th of an inch, so I'm happy. And I got a much more positive grip here. Don't have as much stick out. Probably should have done this to begin with, but I was trying to stay true with it and turn it like I think it was turned originally, which was between centers, but this will work just fine. So back at it, we're going to come in here and finish thinning out that flange. I want to get it down probably about the top up there be about 100 thousandths, 150 thousandths thick. And I'm just taking a little bit at a time, facing that off. See where we're at. So I'm about 180. I'm going to take it down to about 150, I think. Put an indicator over here on my carriage. Probably do 2 15,000ths passes and we should be there. Perfect. So now I want to come down here and get this turned down to 5/8. 725, 100 thou more to go. $625. So we've got a pretty big chamfer up on the front of that original. So I've got a chamfer tool in here. And again, I'm just going to make a nice, pretty big lead-in chamfer. And while I got it in there, I'm going to come over here and just break the edge on this surface. I'm not really wanting to chamfer it very much, but I don't want a sharp edge there either. All right, that looks good. Up next, if you look at the other flange here, it's just round on the outside. The inside is relieved, and that way you're just got a nice outside surface that it's contacting. So we're going to relieve some of that inside out. I've got some marks. It's about 3/8 of an inch from the edge. I can kind of see where I'm at. I've rotated my cutter so I can get right back in there into that root. I'm going to feed in, and then we'll just come out, and I can see my mark that I made in there. Which is about right there. Make that a little bit deeper. We are getting ready now to do our left-hand Acme threads on here. So we're going with a 12 pitch, 5/8, 12 Acme threads. And I've got the lathe set up over here. Acme threads are at a 30-degree included angle rather than a 60-degree angle like a typical thread. So I've got my compound set on 19.5 degrees, which is a little bit different angle. And also, since we're doing left-hand threads, we're going to be threading out instead of coming in. So I actually have my compound shifted around in the opposite direction than normal. Left-hand threads, I cut them just like I do right-hand threads, just backwards, so no big deal there. Now, as far as depth of cut, according to the math, it should be 52 thousandths, should be after I touch off. I've got a dial indicator set up here to kind of keep track of that, but as we get close to it, we'll test it with a test fits. Let's start by firing up the lathe. I should have everything set, and again, left-hand threads, I've reversed the direction of my travel. Normally on a right-hand thread, you're going to thread in, and on a left-hand thread, we'll thread out, and that'll give us that, what we need. So I'm going to just come in here until that just touches. And I'm going to zero my indicator right there so I can keep track of how far we're going. And I'm going to wait for a number to come around, and then we're going to let it roll out, and I will check my thread pitch to make sure we're good on 12 threads per inch. All right. Got my Acme thread pitch gauge here, and yes, we are on 12 threads per inch. So let's do it. Feed in, do about 10 thou on the first pass here, wait for our number to come up. So on these left-hand threads, I'm just going into my zero here, and we're at about 45 thou deep right now. I'll wait on my number to come around, and we will thread out. According to the math, we've still got about 10 thou to go, but when I start getting close, there's nothing better than a test fit, and we are still a little bit on the large size. So let's take a little bit more. Go back to my zero. I'm just going to take a few thou here. I'm at about 48. And let's do another test fit. Keep in mind when you're doing these test fits on these left-hand threads, see there? That's a perfect fit. But you need to spin your nut backwards. And we were a little bit shy, about 2 or 3 thousandths shy of what the book says on the depth, but we're there. Let's try it out. Here's a 10-inch saw blade, like would go on that saw. That fits right up on there. Put our big flange on there. This is a washer, or a nut rather, that I have for one of my table saws. We got him one ordered. But that should be fine. And no, I'm not going to run that, guys. Sorry. That would be super, super dangerous and super stupid, but I do want to do a mock-up test fit. All looks good. The lathe work is done. I've still got 2 operations to do to this, but I'm going to have to be done for today because I got to get some stuff in here to finish this thing out. So here's the original arbor. Here's the new arbor that we just finished making. And the final 2 things is, number 1, we need a Woodruff key slot here in the shaft. If I remember right, I checked it. That's a 3/16 by 3/4 inch radius or diameter, I guess. Woodruff key that goes in here. I do not have the proper key set cutter for that. I just checked over in my stock, so I'm gonna have to order one of those and cut that over on the milling machine. The other thing is if you look, there's some flats on this round part, and they're just 2 flats where a wrench can go on there to tighten that up. I've got to cut those as well, and we'll do that over on the milling machine. But to do that, I'll use a collet block that I can just flip over 180 degrees and get those 2 flats on there. However, I don't have a 5C collet that is a 17 millimeter to fit that shaft, so I'm actually going to need to order a collet as well. So got a couple of things to get in, and whenever I do, we will finish this project up over on the milling machine with those 2 quick operations. So with that, that is going to be a wrap, guys. We've got the turning work done here on this new table saw Arbor for Bruce, and a little bit of work there, a lot of metal to go from a big chunk like this down to a little spindle. Most of it ended up in the chip pan on my lathe, but fortunately we found this part buried inside that piece of steel right where it needed to be, and I think it's going to serve him well. So with that, guys, that's going to be it. As always, thanks for watching. Please subscribe to the channel if you haven't already, and those comments and thumbs ups are always appreciated as well. And guys, with that, we'll catch you on the next video. Thanks for watching.